Welcome to the 10th class mathematics chapters. Okay. Today we'll learn about the statistics. Okay. Statistics is one of the very important chapter from the competitive exams point of view as well as for the future. Okay. In the most of the industries, if you see here today, the terms which are very buzzing are AI, data science, okay, artificial intelligence, data science, machine learning. Okay, so these are all the root of core of the science behind all these things is statistics. Okay, if you are good in statistics, okay, then this is where you can actually pursue your future. Okay, these are the areas where you can pursue your future. And if you see most of the games today, okay, sports and games like cricket or football, lawn tennis, whatever you see a lot of statistics coming appearing on the screen, in the TV screen, or even in the real ground. They are nowadays presenting the statistics. Okay, so this makes the game very appealing, and people feel that they are aware of the game very well, and they can make guess actually, right? So this is one of the very important chapters, and as I said again, the 10th class statistics is slightly improved version of ninth class statistics, where you were only learning the simple data. Okay, you're applying statistics on a simple singular data. Now you have grouped data. Okay, so how to apply the same things what you learned in ninth class on a different set of data. Okay, data pattern is different here. Instead of continuous data, it is different. So let's learn this. These are all basics for your future. And as I said, in 11th and 12th, statistics and probability will be one of the huge thing where you can score easy marks, and they are less time consuming. Okay, so let's get into the chapter. What we learn in this is the 14th chapter in Telangana class 10 book. We'll learn about introduction, mean of ungrouped data, then median of group data, central tendency, then graphical representation of cumulative frequency distribution, obtaining median from a given curve. Okay, and exercises along with it. Okay, yeah, that's it. Introduction. Okay. Yeah, statistics, as we know that this is you're given a set of data, and it is up to the statistician to present it to the most useful way. Okay, so Ganesh recorded the marks of 26 children in his class in mathematics. Okay, summative assessment is here. Here is the 26 students' data, but this is the raw data. Okay, what can I derive from here? I don't want to, if there are, let's say, 50,000 people data I am collecting and it is represented like this. What is that I will do with the data? This is not organized, correct? So first thing is we need to organize data. It is easy for 26 students. I can go and check each individual one. But if it's 26,000, or I mean 26 lakhs, 26 crores, then what you will do? Okay, so we need a grouping of data, correct? So we'll group it something like this. If I summarize this data, I will summarize something like this. Up to 33 marks, there are 4 students. 34 to 50, there are 6 students. 51 to 75, there are 10 students. 76 to 100, 6 students. Now, once this data is known to the teacher, right, then they know who are the children they should concentrate on. Okay, the 0 to 33, 34 to 50, these are the students they need to concentrate more. So this gives an idea instead of going through each and everybody, right? So this is the advantage of representation of data. Okay. Now in this chapter, first we'll start learning mean of ungrouped data, which we have learned before. But yeah, let's just start with this. Okay, mean or so I mean others call it average in a normal term. Okay, his observation is sum of values of all observations divided by total number of observations, right? If it is simple data, sum of all numbers divided by number of terms. Okay, so sum of all observations, if only frequency is given, suppose, okay, group data is given in groups, and then frequency is given, then how do you represent? Mean of data is if f is frequency and x is the class or group, then f1 x1 plus f2 x2 up to fn xn divided by frequency, sum of frequency. Because this is called group of, sorry, mean of the data. Okay. So we call it x bar. Okay. We call it x bar. Or in other terms, sigma is basically sum of repetitive numbers. So we can represent x bar or mean as sigma f1 x1 divided by sigma fi. Okay. It's same as this. Okay. Exactly same as this. Okay. So this is the representation in mathematical field. That's it. Okay. Let's start with examples. There are not much theory in this. You have set of equations and formulae. Only thing is you need to understand the real problem and see how we can group it, how we can represent it. Okay. The marks obtained in mathematics by 30 students of class 10th in Rangayapalli school are given in the below table. Find the mean of the marks obtained by the students. Okay. 10 marks, one student got. 20 marks, one student got. 36 marks, three students. So this is the uh, marks, group of marks, and this is the frequency of students. How many students got these marks? Okay. Total is 30. It is sum of frequency is 30. Okay. Now I know marks obtained, the group here, and I know the students. Okay. Frequency. So F1 Fi Xi I am calculating. This is 10 into 1, 10, 20 into 1, 20, 36 into 3, 108, similarly, and then sum up everything. Okay. So I have my sigma Fi Xi and sigma Fi. Okay. So mean is nothing but sigma Fi Xi divided by sigma Fi, which is 1779 divided by 30, which is 59.3. Okay. So this is the very simple way how you get the mean of a data given, right? Now, let's say in most of the real life situations you may not get exact these numbers. Okay, let's say every student get a unique mark, then you cannot say 10. I mean, you have to start telling from 1 2 3 4 up to 95, correct? So that is not possible. The tabular data will increase, right? So one thing we do is we group the data basically. Okay, we group that into intervals like 10 to 25, 25 to 40. Okay, you take exactly same interval. 25 minus 10 is 15, correct? 40 minus 25 is 15. So everywhere you take same interval and group the data, and the same data is represented as this one, class interval and a number of students. This is also frequency. If you sum up, you will get again same 30 students, and all the students have, these are the marks group of class interval. Okay, 10 to 25, 25 to 40, 40 to 55. Okay, you can choose what is your appropriate class interval. You can have less, you can have more, or you can how many you want. Based on that, you can decide. Okay, now with this data, if I want to calculate the mean, okay, okay, so upper class limit in the class mark is upper class limit plus lower class limit by 2, correct? That's what we do normally. We need basically, how do you multiply in this? If you see in this table, I multiplied 10 into 1 as 10, correct? Xi is 10 for me. But from the class, if I group it into class, how do I get the Xi value, correct? So Xi value is given nothing but 10 plus 25 by 2. 25 plus 40 by 2. Basically midpoint. Take the midpoint of this class boundaries, and then that is your xi. Okay. So upper class limit plus lower class limit by 2. That's a midpoint, right? What you get. So if this is the class limit, and this is the frequency, then I need xi. Xi is nothing but midpoint. So 10 plus 25, 35 by 2, which is 17.5, 32.5. This is my xi. Okay. Once I know the xi, I need to multiply this, right? Fi xi. Okay, so this is the values I get and divided by 30. Okay, now let's see what is the value I got is 62. Okay, this is around 62. In the initial calculation, how much we got? It's around 59.3, which is more accurate, definitely. But as I said, when the number increases, this is for 30 students, so it is easy to represent the data like this. But if you have 30 lakhs people. You cannot represent data like this and sum up, correct? So you are calculating a grouped data. Okay, you are grouping the data into some classes and then calculating the mean. Okay, you will get approximately close to the central mean value. Okay, so this is how we calculate the mean of a grouped or class data. Okay, when class interval is given. Okay, this is called a direct method. Okay, this is very simple, right? I just have a classes. I just have classes and I just take the midpoint of the class, just multiply with the frequency, sum up, and then divide it with the frequency. That's it. This is a direct method. Okay. So remember, there are three methods to get the mean. Okay. Direct method, assumption method, I think second one, and third one is step method. Okay. So three methods are there. All three will we try to converge close to this 59.3, right? This is the actual mean. So we need to converge close to that value. So let's see how we will do that. Okay. So this is the direct method. Now, yeah, the questions here are obviously we answered, but let's read it again. The mean value can be calculated from both ungrouped and grouped data. Which one do you think is more accurate? Obviously, ungrouped data is more accurate. Group data will come close to the accurate. Okay. But ungrouped data is very a lengthy process if you have the frequency very high. Okay, if the total number of people where you have the data is very high, it's very difficult to calculate the ungrouped data mean. Okay, which is more convenient. That's what we are talking about. Okay, group data analysis is definitely more convenient. It's easy and faster, and it can scale up to any level. Okay, you can calculate 60 crores data, 60 lakhs data, whatever number, you can still group it into 60, right? All 60 crore data, I can group it into 60, right? 1 crore class size is 1 crore, and then I can just make it to 60, right? So that's easy. Let's see. Okay. Uh, Now, sometimes when the numerical values of xi and fi are large, finding the product of xi and fi becomes tedious and time consuming. Okay. Yeah, that's true. For such situations, let us think a method of reducing these calculations. Okay, the second method we are doing only to reduce the calculations. Okay, we are not telling the second method is better than the first. Okay, or the first is better than the second. It is all about how much data you have and choose which one is easy for you. Okay, so frequencies we normally don't touch anything. Only thing we fiddle with is basically xi data. Correct. So we calculate the deviation. That is the main thing. Okay, this is the deviation. Okay, let's say the second step is to find the deviation of A from each of these xi's. Okay, so you choose one of the number as a deviation. Okay, assumed mean we call it. A is assumed mean. Okay, we think that let's say 47.5, we take the middle value and we call it assumed mean. You can take any number. Okay, we just taking this 47 point as assumed mean, and then find out how much is the deviation of each class marks from this assumed mean. Okay, so 17.5 minus 47.5, which is minus 30, 32.5 minus 47.5, which is minus 15. And obviously here it is same, so it is 0. Then it is 62.5 minus 47.5, which is 15, 30, 45. This is my DI. Okay. So now I have DI data. Instead of calculating FIXI, I calculate FIDI. Okay. So what I am trying to do here is if my class average is very big, basically, I'm taking only the deviations. Okay, all of them most probably same, right? They will be same steps. So by choosing one of them and finding the deviation, they will be most probably simple integer or very simple decimal values, correct? So with this, if I calculate, I get FIDI. Okay, so minus 60, minus 45, 0, 90, 180, 270, and sigma of FIDI is 435. Okay, now my deviation is mean of deviation. Okay, my mean of this is not mean. Okay, this is mean of deviation is sigma fi di divided by sigma fi. Okay, now let us find the relation between this deviation and xi. Then we know how to calculate xi. Correct. So deviation is fi di, which is nothing but I will write di as xi minus a. That's what I have done, right? Every xi I took and I subtracted the assumed mean. Correct? Xi minus a. So di I am writing it as xi minus a. Then it will become sigma fi xi divided by sigma fi minus sigma fi a divided by fi. Okay. So this is nothing but this is my actual mean. Correct? So that is x bar. Then a is constant. It won't change. So a into sigma fi by fi, which is 1. Correct? So deviation is nothing but mean minus assumed mean. Okay. So I have deviation I calculated. I know what is my assumed mean. So how can I get mean? Mean is nothing but a plus deviation. Deviation is nothing but sigma fd by sigma f. Correct. So this is how I calculate my mean from the deviation. So this is called deviation method or assumed mean method. Okay. So because I making a assumption first, assumed mean, and then finding the deviation from that, calculating the mean of the deviation, subtracting it from the assumed mean. I mean adding it to the assumed mean. Then I get the actual mean. Okay. So with this method, if I apply same thing, what I am getting is around 62. Okay, around 62 for the same data, which we got before. How much we got? Uh, 62, which is same. Exactly in the group data method, we got both of them same. Actual one is close to 59.3, but we are getting in both the methods around 62. Only difference is second method is slightly better, easy to calculate compared to the first method. Okay, so okay, this is the marks, average marks obtained by the students is 62. Okay, now calculate the data in the given example 1 and calculate the arithmetic mean by deviation by taking the successive values of xi. Okay, each time you take assumed mean, different assumed mean. Why I choose 47.5, but I can choose anything, right? So try doing that exercise yourself, and you'll find that whatever you take, basically you will get the same mean. Mean value will be same. Okay, so that is what we are trying to tell, which you can experiment yourself. Okay. Okay, now there is one more method. Okay, there is one more method with which we can calculate the mean. Okay, so let's see this method from the example directly. We can see this is the given class interval. This is the frequency. We have the class marks here. We have assumed mean as 47.5. So di is this one deviation. Correct. Now deviation divided by h. H is nothing but class size. H is nothing but class size. Class size is 15 here. H is equal to 15, right? So if I divide minus 30 with 15, I get still smaller number, minus 2, minus 1, 0, 1, 2, 3. This is much smaller number. This is more complex here. This is slightly better here. This is more better here. Okay. So I'm trying to calculate uh, another ratio I'm applying basically to make it very, very simple. Once I have this data, this is my Fi, this is my Ui, Fi into Ui. Okay, I have sigma of 29. Now, this is nothing but what is this value? Fi Ui by Fi will be my U bar, correct? My U bar. Okay, that is whatever. Okay, step method or whatever you call. This is my U bar, and then U is nothing but xi minus a by h, correct? Xi minus a by h. So 1 by h, if I take common, this will become x bar minus a. Okay, so 1 by h into x minus a equal to u bar. So x bar equal to a plus h u bar. Okay, So with this data also, I can actually derive my mean value. Okay, so this is more simple. This one is more simple. This is also assumed method or direct method. Uh, it's pretty simple. Okay. So with this also, if you calculate how much I get exactly 62, which is same. Okay. So this is another method we call step deviation method. Okay, this is called step deviation method. So we have seen three methods of calculating mean of grouped data. First one is direct method. Second one is assumed mean method or deviation method. Okay, this is my second one. Okay, and third one is step method. Okay, so all three methods will give you the exactly same value of the mean. Okay, which may not be exactly close to the actual mean value, but it will be very close to the center value. I mean, mean value of the actual mean value of the data. Okay. Step deviation method will be convenient to apply if all DIs have common factor. Okay. The mean obtained by all these methods is same. The assumed mean method and step deviation methods are just simplified forms of direct method that we know. The formula still holds if A and H are not given, not as given above. Okay. But are any non-zero numbers such that UI is equal to this value. Okay. So let's do some examples. Okay. And then get into the exercises. The table given below, the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories of India. Find the mean percentage of female teachers using all the three methods. Okay. So this is the data we have in a class form in the, okay. So first thing is very simple. Um, let's take it as 50. Okay. First thing, okay, you can do it here. This is my class group. This is my frequencies. This is my central tendency 25 plus 15 by 2 xi. Okay. So my fi xi is here. So the actual direct method f sigma fi xi by fi, which is 1390 by 35, which is 39.71. Okay. This is my actual mean of the group data. Okay. Now I took A as, if I say 50 here, okay, A as 50. So my DI is minus 30, minus 20, minus 10, 0, 10, 20, 30. Okay. And then with this, I get the F5 DI, okay, which is sum is minus 360. So my mean from the assumed mean method is A plus sigma Fi di by Fi, which is 50 plus minus 360 by 35, which is nothing but around close to 39.75, which is exactly same as actual direct method what we calculated. Okay. And in the step deviation method, my H is class size. Class size is 25 minus 15, which is 10. So all the data will become more simple. Minus 3, minus 2, 1, 0, 1, 2, 3. And then my FIUA is here. Product of SI unit. Sum is minus 36. So it will become 50 plus minus 36 by 35 into 10, which is exactly same here if you see. Correct? So it is again 39.71. So all three methods actually have given exactly same mean value. Okay. It may not be true that every time you get a same value as direct method, but they will be very close to the value of the value calculated using direct method. Okay. Okay. Let's do another one. The below distribution shows number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does the mean signify? Okay. So these are the statistics I was talking about beginning. Okay. Most of the sports are becoming interesting because all these statistics are shown actually on the TV screen and in the magazines, wherever it is. Okay. So these statistics are making these games more and more appealing and interesting. Okay. So here, number of wickets, we have a class from 20 to 60, 60 to 100, 100 to 150. Okay. So these are the classes here. But if you see this, the class range is not exactly same. Okay. All the class range is not same. How do you calculate for this one? Okay. You apply same method. Okay. 20 to 60, 7, 60 to 40, 5. Okay, the frequencies here. Okay, and then my xi value is 40, 80, 125, 200, 300, and 400. If you see, they are not exactly in the arithmetic mean, arithmetic progression, right? Okay, so my deviation, if I take 200 as a, this is my deviation, and this is my u value. Okay, deviation divided by class size. This is the value here. Okay, and this is my fi ui. Okay, so using the step method, if I calculate, it will be x bar equal to a plus sigma f phi ui by sigma f into h, which is equal to 200 minus 47 by 0.11, which is 152.89. Okay. What is the meaning of this one actually? First thing, what is the meaning of mean, what you are calculating? Okay. This is the, if I see the question here, it is talking about number of wickets, number of bowlers, right? So if I divide number of wickets by number of bowlers, what I will get is average number of wickets taken by bowler. Right? So this is my mean. This mean tells that average number of wickets taken by these 45 bowlers in one day cricket is this one. Okay. So there are so many things which you can actually take the real data and then calculate and represent the data in a beautiful way using mean. Okay. All three methods actually give you mean, slightly different, but more or less all the mean is same. Direct method gives you more accurate. Other two methods give you easy way of calculating or faster method of calculating, but the value may not be as accurate as the direct method, but they are very close to that. Okay. So let's do these exercises and learn more. Okay. Statistics theory part, as I said, theory is very, very small. It is not very complex. It's all about practicing without making any numerical mistake. You have to do these problems. So let's do these exercises. Let's do the exercise 14.1. Okay. A survey was conducted by a group of students as part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants per house. Okay. So almost all the questions in this chapter will be something like this. They give some data to us with a class and frequency. Okay. Then they ask what you want to find out. Okay. Here in this question, it is about mean. Okay. Mean of the plants. So data given is this one. I just represented in a vertical table. Okay. So this template will be mostly same for all the questions. Maybe you will get a different columns depending on the question. Okay. So number of plants, this is the class range. Okay. Then I need xi. Xi is nothing but average of this upper bound and lower bound, right? So 0 plus 2 by 2, which is 1. Okay, in this case 3, 5, 7, 9, 11, and 13. Okay, this is the frequency. So FIXA is here and the sum of FIXA is here. So it's very simple. Mean of the plants as per direct method is this one, right? Direct method. Okay, 162 by 20, which is 8.1. Okay, yeah, next. Again, same, some data is given in tabular form and you can see the class here and the frequency here. So I just kept in vertical tab, class, frequency, xi is the average of these two. Okay, upper bound and lower bound. Then fi and fi into xi, okay, product of these two. Okay, then sum of it and then average is using direct method is this one, right? 313. Next. Okay. Following distribution shows the daily pocket allowance of children of a locality. The mean pocket allowance is rupees 18. Find the missing frequency. Okay. In this question, slightly different. They gave the mean already. Mean is 18. Okay. And one of the frequencies is missing. Okay. Which they want us to find. Okay. So I'll just put in the same vertical tabular form. F here. Okay, then I know this frequency is not given, which is f. So total sum is 44 plus f, and the product FIXI is 750 plus 20f. So once I know this, okay, so this is the equation which is given as 18. So 18 is equal to 750 plus 20f by 44 plus f. So just solve this for f. So what you will get is f is equal to 20. Okay, next. Okay, yeah, 30 women were examined in the hospital by a doctor, and their heartbeats per minute were recorded and summarized as shown. Find the mean of heartbeats per minute for the woman. Choose a suitable method. Okay, so I choose direct method here. Okay, and then direct method is simply the class here, frequency here, xi is here, fixi is here, sum of fixi is here. So it's 75.93. Simple. Okay, this is the average heartbeats per minute of for these women. Okay, next. In a retail market, fruit vendors were selling oranges kept in packing baskets. These baskets contained varying number of ranges. Following was distribution of oranges. Find this mean number of oranges kept in each box. Okay. Which method of finding the mean did you choose? Okay, they are asking which method also. Okay, so this is the class frequency xi fixi. Okay, sum of fixi. So 8925 8925. So I choose direct method. Using direct method, these are the mean, that is 22.31. Okay, next. Okay. The table below shows the daily expenditure on food of 25 households in a locality. Find the mean daily expenditure on food by a suitable method. Again, same thing. So if they don't give you any specific method, you just choose the simplest one, whichever is you think is simple. Okay. Daily expenditure, class, frequency, xi, fixi, sum of fixi here, 5275. And then using direct method, this is the average. Mean is 211. Okay. Next. To find out the concentration uh, of SO2 in the air, the data was collected for 30 localities in a certain city and is presented below. Find the mean concentration of SO2 in the air. Okay. It's almost all the problems are same. They give a class, they give a frequency, you write it in the proper format. Okay. Concentration of SO2, frequency, then xi, average of these two, and then fixi, and then sum of it. Okay. So using direct method, the mean is 0.99. Okay. So this is 0.099. Okay. So just note down 0.099 it should be. Right. If I remove 10, it will be 0.296. Okay. It should be 0.099 ppm. Okay. Yeah. Next. A class teacher has the following attendance record of 40 students of a class for the whole term. Find the mean number of days a student was present out of 56 days in the term. Again, you have the class here. Okay. You have the class here, you have the frequency here, you have the xi here. Okay. So just for a change, I choose the second method. Okay. So here deviation method. So deviation is xi minus a. A I choose as 45.5. I choose. Okay. So this is the deviation here minus 36.5 minus 45.5. Okay, which is minus 9.5. Okay, this is the deviation of second class. That is minus 6.5 minus 3.5 0.369. Okay. This is my FIDI. Okay. This is sum of FIDI. Okay. Now using deviation method, mean of oranges is equal to A plus uh, sigma fi di by sigma fi, correct? So it will come approximately 49, 48.925, which is approximated to 49. Okay, next. Following table gives the literacy rate of 35 cities. Find the mean literacy. Okay. So here I choose uh, the step method. Okay, just to show okay how it will be. Okay, the class is here. Same thing. Class is here. Frequencies are written here. Sum of frequencies 35. Xi is here. Your xi. Okay. Then deviation is here. Ui is here. Deviation by h. H is the class. Class is 55 minus 45, which is 10. Okay. So deviation is here, and then FIUI, okay, which is sum is -2. Okay, now using step deviation method, okay, FIUI by FI, which is -2 by 35 into H, which is 10. So minus 20 by 35, uh, then plus 70, which is 69.43 percentage is what the mean percentage, mean literacy rate. Okay, next, yeah, more. So these are the examples. Almost all the problems you can choose any method to solve. Just for your example, in case in the examination they ask a specific method to solve, then you know how to do it. Okay. Now let's learn about the mode. Let us learn about the mode. Okay. So as we know in the previous classes, we have learned what is mode. Mode is the value. Okay. That among the observations, this mode value occurs most frequently. Means if you have 10 values, 10 numbers given, okay, mode is a number which is basically repeated most number of times among these 10 numbers. Okay, just we will explain using example. The wickets taken by a bowler in 10 cricket matches are as follows, as follow. Okay, 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. So find the mode of the data. Okay. First thing you do is you arrange them in order so that either ascending or descending order, then it will be easy for you to check the mode. So this is the ordered numbers. Okay. So among this, 2 is repeated 3 times. Correct? 2 is repeated 3 times. And this is the maximum number of times a number is repeated among this 10. Correct? So this is the mode. So mode simply says that, okay, this is the number which is most frequently occurred in this group of data. Okay. So is it useful? Yes, it is useful. Sometimes you want to know what is the most frequently used number, right? For several examples, you can, it is useful. So this is the mode. Now this is for the ungrouped data, which we have learnt before. Now in this chapter, we will also learn mode for the grouped data. Okay. Before going that, let's see. Find the mode of the following data. Okay. So first is you have to write in the sorted order. Okay. So for me, it looks like 6 is the most number of times repeated. Okay. Because it is 4 number of times. So similarly, other things you can do. And this example, if you see 2, 3, 4, 5, 6, all of them are used to more number of times. I mean, equal number of times. Okay, occurred equal number of times. So you can take the average of these numbers. That's a mode. Is the mode always at the center of the data? Definitely not. Okay, mode does not depend on the center of the data. Okay, but there are high chances because this is occurring more number of times. It may go up to the center. Correct. So that's a does the mode change if another observation is added to the data in example 4? Yeah, definitely mode can change. If let's say in this one, if you add another 3, mode value is changing, right? Okay. Next is if the maximum value of an observation in the data in example 4 is changed to 8, would the mode of the data be affected? If this is the maximum value, so 6 is changed to 8, okay? Is the mode affected? No. Okay, not necessarily changing the number of biggest value will influence the mode. Okay, it is independent basically. If that is the number uh, which is mode most frequent times occurring, then it may change, but otherwise no change. Now let us discuss about the mode for the grouped data. Okay, the formula is given here. Just to remember it. We will go through this and understand this how this is coming. Okay, so mode is equal to L plus L is nothing but lower boundary of the model class. First thing we have to do is from the grouped data we have to determine the model class. So how do you determine model class in this example? Which one is most frequent group in this one? That is 8. Okay, there are 8 families in this group, right? So this is the most frequent. So this is the model class. 3 to 5 is the model class. So lower boundary of the model class is 3 in this example. H is the size of the model class, that is 5 minus 3, which is 2. Okay. F1 is frequency of the model class, that is 8. F0 is frequency of the class preceding to the model class, that is 7. F2 is frequency of the class succeeding the model class, that is 2. Okay, and once you know this is the equation you have to apply. Lower bound plus F1 minus F0 divided by 2F1 minus F0 F2, okay, multiplied by H. Okay, so let's calculate for the example data here. Okay, this is the survey conducted on 20 households in a locality by a group of students, resulted in the following frequency table for the number of family members in a household. Okay, family size 1 to 3, there are 7 such families. 3 to 5 is family size, there are 8 families, and so on. So now we already discussed actually 3 to 5 is the model class because most number of families belong to this group. Okay, so lower boundary of that one is 3. Class size is 2. Model class frequency is 8. Preceding class 7. Succeeding class 2 frequency. So if you submit all these values properly replace, then what you will get is 3.286. This is the mode of the data. Okay. Now, another example, the marks distribution of 30 students in a mathematics examination are given in the following table. Find the mode of the data. Also compare and interpret the mode and the mean. Okay. So we have to do both in this basically. So first is for mean, we know we write the class here, class interval, fi, that is frequency, and then we find the xi, which is 10 plus 25 by 2. Okay, and then fi xi, that is here. Correct. So sigma fi xi, which is 1860, and sigma fi is 30. So mean is simple. Mean is sigma fi xi by sigma fi. Okay. So mean here is I think around 62. Okay. We have done the same example before. So the mean is 62. Okay. So now mode we will calculate. Okay. Maximum number of students belong to this, right? 7. So this is my model class. Okay. And this is my uh, preceding, this is my succeeding frequencies. Okay, and class size is 55 minus 40, that is 15. Okay, so I have all the data already in place. So mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. If I substitute the values, what I will get is around 52. Okay, so the mode is 52, mean is 62. Okay, so mean says on average, okay, on average, 62 students is the class interval. Okay, and mode says most of the class intervals is 52. Basically, 52 is the 52 number of students for the most of the class intervals. Okay, so that's the difference. Okay, it depends upon the demand of the situation whether we are interested in finding the average marks obtained by the students or the marks obtained by most of the students. Correct? Yeah. Who do we find in the first situation? In the first situation, we are finding the average of the marks obtained by the students. Okay. How, on an average, how the class is performing. Okay. That is the first question answers. That is mean. Okay. And the second one, mode answers. What is the maximum number of students? How many marks they are getting? Okay. How can, so if I concentrate on those numbers, those people, I can actually improve them. right? So the average automatically increases. Okay. So this is the difference of mean and mode. Okay. Can mode be calculated for grouped data with unequal classes? Yeah, definitely it can be actually calculated. We have to just find out the, let's say all class intervals are different. Even then, based on my frequency, I choose the class. So class interval H is based on this value. And after that, I need only frequencies. I don't need anything. I don't need anything to do with these other class intervals, right? So you can calculate mode for the classes with unequal class sizes. Okay, let's do the exercise 14.2 now. Okay. The following table shows the ages of patients admitted in a hospital on a particular day. Find the mode and mean of the data given above. Okay, compare and interpret two measures of central tendency. Okay. So age group 5 to 15, there are 6 patients. Okay, 15 to 25, 11 patients. So 25 to 35, 21 patients. 35 to 45, 23 patients. 45 to 55, 14. 55 to 65, 5 patients. So first thing is for finding the mean. Both measures we need, right? So for finding the mean, you write the class here. Fi you have frequency. Xi you will get 15 minus 15 plus 5 by 2. Okay. Then FIXI which is 60. So we have sum of FIXI which is 2830 and frequency sum of frequencies is 80. From this we can easily get the mean. Mean is 35.375. Okay. And for mode, okay, frequency is 23. This is my model class 35 to 45. So L is 35. Class size is 45 minus 35 which is 10. Okay. F0 is 21. Okay. Preceding class and F2 is 14. Okay. Now you substitute the values. What I will get is mode as 36.81. So if you see here, it is close to the average. Okay. But it need not be. Okay. That's you have to understand. It only tells where is the central tendency, where is the maximum bulk of the weightage is going on basically. Okay. So yeah, this is the next. Many patients' age is 36.81, whereas mean of patients' age is 35.37. Okay, next. Again, all the questions template is same. Depending on what they are asking, whether mode or mean, you need to make your table accordingly. Okay. Following data gives information on the observed lifetimes of a 225 electrical components. Determine the model lifetime of the components. Okay, so this is simple. I don't need. They asked the model, so I need to find the mode. For mode, I need first is highest frequency is this one, 61. So model class is 60 to 80. So my L is 60, H is 20, 80 minus 60 is 20. Okay, frequency of preceding class is 52, succeeding class is 38. Now this is the mode equation. So if I substitute the values, what I will get is mode is 65.625 hours. Okay, this is the life of a model lifetime of a component. Okay, next. The following data gives the distribution of total monthly household expenditure for 200 families of uh, Gummadidala village. Find the model monthly expenditure of the families and also find the mean monthly expenditure. So they asked mean, so I need this table here. So same data basically I put it in the table here. Class is here, frequencies are here, my xi is here, which is nothing but lower limit plus upper limit by 2. Okay, mid value of this one. And then FIXI. This is sum of FIXI and this is the sum of frequencies. So my mean is simple. 5,27,000 divided by 200, which is 2,635. This is the average uh, household expenditure of the family. Okay, average household expenditure of the family is 2,635. Okay, now for finding the mode, what we have to do first is which is the most frequent data, that is here 40. So model class is 1500 to 2000, L is 1500, H is 500, 2000 minus 1500. My F0 is 24, F2 is 33. Okay, and then you substitute the values in the equation, mode equation, then what you will get is 1847 dot point 83. This is point actually decimal point 83. 1847.83. This is the model data. See the difference? There is a huge difference. So mode need not always uh, get close to the mean. Okay, next. The following distribution gives the state-wise teacher-student ratio in a secondary schools in India. Find the mode and mean of this data. Interpret the two measures. So yeah, you will actually do the exactly same thing what you have done in the last example. Only thing is, yeah, mean is around 29.21. Okay, whereas mode is around 30.625. Okay, so my interpretation is mean of students is 29.21, whereas most states have student teacher ratio as 30.625. This is the average student teacher ratio of the all the states. Average is 29.21, whereas most states have to student teacher ratio as 30.625. Okay. Yeah. Next. Yeah, you need to find the mode of the data. So we don't need to explain again. The template is exactly same. High frequency is here. So this is my model class. L is 4000, H is 1000. Okay. F0 is 4. Actually, F0 should be 5. Okay. And F2 is 9. Okay. So you substitute the values actually slight. This should be 5. Okay. This should be 5. So what you will get is actually 13 by 23 into 1000. It will be slightly lesser than this. Slightly. Okay. Not too much. Okay. Yeah. The value will be slightly lesser than that. You calculate yourself correctly. Okay. So I will just mention here. Uh, okay. Recalculate. Redo. Okay. Redo yourself. And I told you where is the problem also. So calculate and get the exact value. Next. Okay. This is again find the mode of the data. So simple. Same thing you apply. Okay. This is the model class. So preceding frequency is 12, succeeding frequency is 11. So if you substitute, this is the value you'll get. Mode is 44.70. Let's learn about the median of grouped data. Okay. We already know what is median in previous classes, right? So median is a measure of central tendency which gives the value of the middlemost observation in the data. Okay. Recall that the finding the median of ungrouped data, we first arrange them in the ascending order and then choose if n is odd number, if number of items or number of observations are odd, then we take n plus 1 by 2 as the observation, which is the central tendency, that is median. If n is even, then we cannot get exactly one term in the middle, so we get two terms, so we take the average of the two terms. N by 2 plus n plus average of the n by 2 term and n by 2 plus 1 term we take, and we take the average of it. Okay, but now let's learn about the grouped data, how to do it for the grouped data. Okay. Suppose we have to find median of the following data, which is about marks out of 50 obtained by 100 students in a test. Okay, so 20 marks, 29, 28, you can see they are in this group. So first thing is we'll sort them out. Okay. So sorting is 20, 25, 28, 29, 33, 38, 42, and 43. This is the order the marks are obtained in the sorted order. And then respective corresponding frequencies are written here. Number of students who got scored those marks. Okay. Now, after this, Since we know n is equal to 100, okay, the median will be average of n by 2 and n by 2 plus 1. Okay, that is 50 and 51, which is 50.5. Okay, so let's see where is the 50.5 marks are falling. Okay, okay. Now, up to 20 marks, we know there are 6 students. Okay, up to 25 marks, there are number of students are 20, right? So 6 plus 20, 26 students got up to uh, 25 marks. Okay. Now, this is a new term which we are introducing called cumulative frequency. What is cumulative frequency? It is sum of frequencies of before. Okay. Sum of frequencies of up to that term. Okay. Up to that class. Okay. Up to 28, how many kids got? Okay. This includes up to 20, up to 25, and up to 25 and 28. Correct. So, this is sum of all the students who got up to 28 marks. So this way we actually form the cumulative. With this, what happens is we know that how many students are, let's say, example, we'll take 50 marks. How many students got, how many students, what is the average marks? 50 students got. Okay, now I can say 50 students got up to 28 marks. Okay, 28 are below or 50 students got. Okay, so this way we can actually uh, find out. Now, in this cumulative frequency, 50th observation is 28, correct? 50th observation is 28. 51st is falling here, 29th, correct? So, the median is 28 plus 29 by 2, which is 28.5. This is the class median class. Okay. Now, this is ungrouped data. So, 28.5 is the median of the uh, ungrouped data marks. Okay. This is correct. Now, let's see. Yeah, we discussed about the cumulative frequency table. Median, we got it. Okay. This says 50% of the students obtained marks less than 28.5. Okay. 28.5 marks if I take, there are 50 students below it and 50 students above it. Right. That's a median. Now let's do how to find it out for the uh, grouped data. Okay. Now you have a class boundary here, 0 to 10, 10 to 20, 20 to 30, okay, of equal class size. And this is the frequency of the students. Okay, if I reorder all those 100 students marks into this group. Okay, now once I have this, I can again write it less than 10 cumulative frequency I need, right? Less than 10 is 5, less than 20 is 5 plus 3, 8. Okay, I have to do cumulative. So add the previous frequency to the individual frequency of that class. Okay, then up to 30 is 5 plus 3 plus 4, like this. Okay, so you got all the cumulative frequencies here, which are 53. Okay, now what is the midterm now here? Okay, how many students have scored less than 10? We know 5. Okay, how many students have scored less than 20? There are 8. Okay, so like this we group it. Okay, and we can also group them. This is less than cumulative, we call it. Okay, because it is less than marks. Okay, now we can also make it more than cumulative. Okay, if I say how many students have got more than 0 marks? Everybody. So this is the total frequency of the sum of frequencies of the students. Okay, more than or equal to 10, then you have to subtract 5 people who are less than 10, correct? So 53 minus 5, which is 48. So this is, we are writing in the descending order. This is, if I call a normal ungrouped data, ascending order is this one, descending order is this one. This is called more than cumulative frequency. Okay, so you have two kinds of frequencies which you can write, less than and more than. Okay, this is how we write it. Okay, once we know that, we just to take n by 2, this is 53 is odd number, so we have to take n by 2. N by 2 is nothing but 53, right? 53 by 2, that is 53 by 2 is 26.5. Okay, So 26.5 is in this group, correct? It is falling in this group. So this is the median. 60 to 70 is the median marks obtained. So you take, correct, 26.5 is the median, n by 2 is the middle number, and 60 to 70 is the class whose cumulative frequency is 29, okay, is greater than n by 2, okay, 26.5. Therefore, 60 to 70 is the median class. Now, once you decide what is the median class, okay, this is the formula you use. Median equal to L. L is lower bound of the median class, n by 2, frequency by 2, minus CF, cumulative frequency of the preceding class. So, if I see here, cumulative frequency of the preceding class is 22, okay, and F is the frequency of the class. Frequency of the class is 7. Okay, don't get confused here. This is frequency, regular frequency. This is cumulative frequency. Okay. CF is cumulative frequency of the previous class. F is the frequency of the model class, median class. Okay. Now, once you know this, and H is the class size. Once you put all these values, you will get the median value, which is 66.4. Okay. So now we can tell that about half of them scored 66.4 marks. That is what we are trying to tell. About half of them scored 66.7, right? That's a value 66.4. Okay, so this is how we try to calculate the median of the grouped data. Okay, this is the formula. Remember this. Okay, now let's do some examples. It's easy to understand. Okay, a survey regarding the heights of 51 girls in class 10th of school was conducted and the data was obtained as shown in table. Okay, find the median. Okay, less than 140, less than 145, less than 150. This is the grouping I am doing basically. This is the frequencies. Okay, cumulative frequencies. If you clearly see, they are all cumulative and 51 girls. Okay, so maximum height is 165. You can see. Okay, now to calculate the median, first is frequency. You form the frequency of it. You keep subtracting, you will get the frequency of this group. Okay, below 140, 140 to 145 is cumulative frequency is 11, so it will be 7, correct? So form the frequencies. Once you know form the frequencies, you know what is n by 2. Okay, 51 by 2 is where it is falling, 25.5. So 25.5 cumulative frequency falls in this group, correct? In this class. This is the median class. Now 145 to 150 is the median class. This is the L value 145, CF is 11, F is 18, okay, N is we know 51. So you apply the all values properly, and H is size of the class, which is 5. 150 minus 145, which is 5. Right? If you substitute all the values, what you will get is 149.03. That means 50%, that is 26, half of the girls' average height is 146, 149.03 is the height of half of the girls or below. 149.03 or below is the height of half of the girls in the given data. Okay. Now, median of the following data is 525. Okay. Now, this is a question where they gave already the median and you find the values of missing values of the frequency x and y. Okay. So, we do same way. First is you write the class intervals here. Frequency x and y we need to find out. Okay. Cumulative frequency will form 2, 2 plus 5, 7, 7 plus x. Okay. Then 7 plus x plus 12, 19 plus x, and keep writing like this. Okay. Now we know that this is the total frequency is 100. N is 100. So n by 2 is 50. So where is 50 falling? That's what we need to check. Okay. In cumulative frequency, where is 50 is falling? Okay. Okay. So first thing is n equal to 100. So 76 plus x plus y is 100. So x plus y is 24. Okay. We know it. Median is 525, which lies in the class 500 to 600. 525 lies here, right? This is my median class then. Okay, because already I know the median. Okay. Okay. This is the class. So lower L is 500. F is 20. Frequency is 20. CF is 36 plus X. H is 100. So 600 minus 500. If I substitute these values, I get an equation in X. Okay. And from this equation, I can solve for X, and X is 9. Okay. X is nothing but frequency of this class. Okay. X is 9. Once I know X plus Y is 24. So if I substitute, I get Y value, which is 15. So this is how I get the value of the unknown data from the if the median and frequency is given. Okay. Slightly twisted question. That's all. Now read this one. Which measure would be the best suited for a particular requirement? Okay, can we tell one is better than the other? Uh, Definitely, we cannot tell. Okay, each one has its own value addition depending on the what data we are taking. Correct. The mean is the most frequently used measure of the central tendency because it takes into account all the observations. You sum up all the observations, then basically average it, right? So this is the most commonly used. Okay. uh, it enables to compare two distributions also. You can compare average to average. It makes a sense, right? Because all the values, average of one group, average of other group, we can compare. But mean mode, we cannot compare really. Comparing two modes have no meaning, correct? Comparing two modes is of no meaning. How which data is most frequent has no meaning. Okay, okay. So go through this one. Each one has its own specific usage when the mean, mode, and median are used. You can just go through this one. Okay. Let's do the exercise part. 10.3. Okay. Okay. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean, mode of the data. Everything, all three values. Okay. So because he has to find everything, so we need the table here. Class F frequencies are here. Xi, Xi is nothing but 65 plus 85 by 2. Okay. Fi then sum of Fi and then cumulative frequency is here, which we required for median calculation. Okay. 4 plus 5 9, 9 plus 13 22, like this. Okay. The total 68 observations. Once we know that, mean is, we know, straightforward, sigma Fi divided by sigma Fi, which is 137.05. Okay. And for mean, you need to derive some values. Okay. F1 is uh, which is the highest frequency. This is 20. Okay. So model class is 125, 145. Lower bound of that is 125. Class size is 20. Frequency of the preceding class is 13. Okay. Succeeding class is 14. So you substitute in these values, you will get the mode as 135.76. Okay. It is important to make this table first. Once you know the table, is just substituting the values in the formula, right? And then for the median, n by 2 is 68 by 2, which is 34. So 34 falls in cumulative frequency in this one, correct? 42, this range. So 125, 145 is the lower boundary of the median class. So this is the lower boundary of the sorry, not model. The median class is 125. Okay. F equal to 20. Frequency of the preceding class is CF. Cumulative frequency of the preceding class is 22. Okay, H is 20. Now you substitute the values, what you will get is 137. So if you see, almost all of them are close to each other. Okay. Of the grouped data, mean, median, and mode are more or less close. Okay. Next. If the median of 60 observations is given below is 28.5, find the values of x and y. We have done this example problem. So this is exactly same. Okay. Yeah, first thing is this is about the 60 observations. So 45 plus x plus y is 60. So x plus y is 15. And then n by 2 is 30. So 30 falls in this You can take 20 to 30. Okay, median class is 20 to 30. So, and given median is 28.5. Okay, so lower boundary of the model class is 20, F is 20, CF is 5 plus X, H is 10. So if I substitute all the values, this is what I will get a equation in X. Okay, or X is equal to uh, 8. Okay, and Y is, from that I can derive Y is 7. These are the values. Okay. Life insurance agent found the following data about distribution of ages of 100 policyholders. Calculate the median age. Okay. Now, again, you put the data here. Most important thing is the cumulative data, which is already there. From that, you derive the normal frequencies. And then once you know that, you already know it. N by 2 is 50. Okay. So 50 falls somewhere here. 45, 50 is the class. Sorry, 50 falls here. Cumulative frequency you have to check. 50 falls here. 78. Okay. In this. So the class is 35 to 40. Okay, class is 35 to 40. Now lower bound is L is 35, F is 33, CF is 45 here, previous cumulative frequency of the previous class, H is 5. Now if I substitute values, median I get is 35.75. This is the median. Okay, so this is another one. You put the table appropriately, just find the median class correctly. Okay. Only thing is you need to adjust the class boundaries here. If you see 126, it is ending, 127, it is starting from. Okay. If class boundaries are not proper, not aligned, then the median values may not be correct because you are missing some data. So better adjust it. You start from 117.5 to 126.5, mid value of 126 and 127. By doing this, you are basically making the class uh, without any breaks, right? So you are not missing any terms, that means. Okay. So readjust it, and then and these frequency values does not change. It shows that uh, three number of leaves of the size 118 to 126. If I consider a class of 117.5 and 126.5, okay, this 118 and 126 falls in the same class subset. So it will be still 3 only. Correct? So that how we'll do frequencies, cumulative frequencies, and then we know it's very simple. N by 2 is 20, so 20 falls somewhere here. Cumulative frequency 20 falls here. 144.5 to 153.5 is my median class. So from that we can get the median value, which is 146.75. Okay. Yeah. Next one. The other one, this is a straightforward question because if you see the class boundaries, they are overlapping each other. So straightforward you can take make the cumulative frequencies and then get the n by 2 200, and then rest all values appropriately substitute, you will get the median life of the bulb is 3406.98 hours, that is. Okay. Yeah, this is the next problem where 100 surnames are randomly picked up from a local telephone directory, and the frequency distribution of the number of letters in English alphabet in the surname was obtained as follows. Find the mean, mode, and median, all three. So you build your table appropriately. Okay, right? You build your table in this way. Classes are overlapping, so we don't need to adjust anything. Frequencies, FI, and cumulative frequency. So mean, mode, and median, you just substitute the appropriate values, you will get. It's a straightforward question. I hope you can do it yourself. Cross check the answers once. Distribution below gives the weight of 30 students of a class. Find the median weight of the students. Okay, this is also again straightforward. Classes are overlapping, so don't need to do much. Just put the cumulative frequency properly, and then you will obtain the value. The median weight is 56.67. Okay. Now next, let's see the graphical representation of cumulative frequency distribution. Okay. The median case, we can actually get the median from the graphical data also, and actually we can represent it. Okay, it makes sense. Okay, So obviously a picture is always easy to compare. So that's the advantage of drawing a graph. Okay. Now let's see all the cumulative frequencies of data if you take. Okay. So you can draw it. It's cumulative. So it will be a continuous line, increasing continuous line. Okay. This is called less than OGU. Okay. It's called less than OGU. Okay. In less than OGU, your frequencies are always continuous and growing, right? Cumulative frequencies. So you draw the cumulative frequency on y-axis and the upper boundaries of the class on the x-axis. Then you get a graph. You call this less than OGU. Okay, this is called less than OGU. And similarly, if you draw the more than OGU graph, it also comes from the maximum to continuously down. Okay, this is the more than OG. Again, cumulative frequency on the y-axis, lower boundaries on the x-axis here. Okay. So these graphs makes a huge difference in directly representing the whole data. You can straightforward compare. You can draw two overlapping graphs also. Okay. And how to obtain median from this given curve. Okay. This is very easy. Once you have the your cumulative graph, cumulative frequency graph, okay, which is here. Now you know that this is a number of sum of frequencies is 53. So n by 2, my n by 2 is 26.5. So I will just check my cumulative frequency around 26.5 here. So if I go to here, then I get my median class, the median value, which is 66.4. This is how from the graph I can obtain median. Okay, this we should know. Once you know this is very easy. Okay, first find out n by 2. Okay, and on the cumulative frequency on the y-axis you mark where is n by 2 and then take the x coordinate of that one, you will get the median of the given data. Okay, otherwise you draw less than OG and more than OG, both will intersect at some point. That is the point median. Okay, so this is very interesting, right? Okay, so this is the use of graphs here and how to represent graphs. Okay, less than OG and more than OG for the cumulative frequency. Let's do some exercise which is very easy. Annual profits earned by 30 shops in a Sangareddy locality give rise to the following distribution. Okay, more than or equal to 5, 30. So you have a decreasing cumulative frequency here, right? So you get more than OG, right? And to get a less than OG data, you have to basically change it first. First, you make it for less than, and then start uh, drawing the graph. Okay, this is the more than OG graph which you represent. Straightforward, right? It's pretty straightforward. You take the lower bound and then just apply. Okay, number of shops are here. Then you can actually get the increasing cumulative frequency. Then you can draw the uh, less than OG, and they will intersect at a point where you get the median. Okay, let's see the 14.4 exercise now. Let's do exercise 14.4. Okay. The following distribution gives the daily income of 50 workers of a factory. Convert the distribution above to a less than type cumulative frequency distribution and draw its OG. Okay. So daily income is given and frequency is given. So I'm trying to convert into the less than cumulative frequency. Okay. So the first data set, that is 250 boundary, whether you want to take or not is up to you. We can start from 300, which is the upper boundary. Correct. You need to take upper boundary. So 300 onwards you can start, but just to start the graph from 0, you can keep the lowest boundary and keep it 0. Okay, less than 250 is 0, right? So we know. So start from this one and write the cumulative frequencies here and graph is shown here. Okay, this is fairly simple. And if you want to know the median of this one, okay, what we should do? We know the cumulative frequency is 50, n by 2 is 25. So you draw a line at 25 here. Okay, so that is around 350 is the median. Okay, if you draw correctly, you'll get the exact value. Okay, next. Okay, During the medical checkup of 35 students of a class, their weights are recorded as follows. Draw the less than type OG for the given data, hence obtain the median weight from the graph and verify the result using formula also. Okay, so let's do first draw it by graph and see what will be the value, and then you will verify it. Okay, so it's a less than OG, so you will write the cumulative frequencies in the increasing order. Okay, so that's what I have done here. So we have to take the uh, upper bound here. Okay, from 38, 40 you will draw. So this is the graph, and we know that total 35 students, so n by 2 is 17.5. So if I draw n by 2 is 17.5, so if I draw at 17.5 horizontal line, it will intersect the graph at a point where the value of on the x-axis is 46.5. So this is my median. Okay, now let's verify the same thing using the formula. Okay, so data is same. We have the cumulative data here. N by 2 is 17.5, so it will fall under 46, 48 class group, correct? So cumulative frequency is 17.5, class is 46, 48. Lower boundary of the model class is median class, sorry. Median class is 46. Okay, F equal to 14. Sorry, this one. F is frequency of the median class is 14. Okay, cumulative frequency of the preceding class is also 14 here, this 14. H is 2. Now you substitute the values, you will get exactly 46.5. Okay, so this is how we can verify. Next. Okay, following again, another data is given. You need to draw the more than type OG. Okay, change the distribution to a more than type distribution and draw its OG. Okay, so I made it greater than 50, all, then greater than 55, 98, minus 2 basically. So you draw the cumulative frequency in this fashion and then draw the graph. Okay, next. Yeah, that's all. Thank you. So this statistics is a fairly simple chapter for you. It is important to know all these basics and practice very well. And from examination point of view, this is very easy problems to solve. And I'm very sure you will get a good amount of problems from statistics and probability. So don't make any mistake. It's only thing you can go wrong is calculation mistakes. There is nothing complicated stuff here. It's fairly simple. So hope you will do well. Okay. I'll meet you with another videos. Till then, keep doing maths. Thank you.